So the best and easiest way to draw your circuit is to start with your power source. So there's my power source, okay? So you know that you have a 6 ohm and a 4 ohm, and they are connected in parallel with each other. So what I'm gonna do is I'm gonna just draw one like this, or actually it could be like this, or like this. There's so many different ways that you could do this, right? And then I could go this way, and I could go that way. Oh, actually they would be in series. Actually, hang on. There's so many different ways. I'm gonna show you the easiest path. Okay, so I'm gonna go this way, sideways. Let's start with the easiest way. I know there's so many different ways. Let's start with the easiest way to draw it. Okay, here we go. Using the least amount of wire, I drew the 6 ohm. So I'm gonna call this one R1. So this is our 6 ohm. This one is R2. This is the 4 ohm. And then you put the 12 volt battery right here. So that's labeled. Okay? So how do I know this is parallel for sure? This is positive, this is negative, yeah? You see right here? What do we call this? That's a junction. This is a junction right here. So if you were to trace the amount that the current that's going through, I'm not gonna draw it because it looks messy. Look at this. Current's gonna go this way, okay? And then if I decided to just go back home that way, this one will be on. This will be off. If I decide to just go this way, that way, this will be on, and this one will be off. Okay?
Or both can be on.
Is there a way that you could turn both on? Well, you could actually see this junction right here. As long as there is no off switch button, they will actually split. That's the Kirchhoff's rule. The current will actually go this way, turn that on, and whatever is left will go this way and turn both on. So R1 and R2 will both be on because there's no switch button. If there's a switch button, you can pick which one is on or off. So that means one can be on, the other one can be off, okay? Unlike in a series circuit, it's all on or all off. In a parallel circuit, you have a choice because you got two paths right here. That means one or both can be on. That makes sense?
So now, it's like this picture, it must be one off, one on?
Well, in this case, they're both on right now because I did not draw a switch.
Okay.
So, but if I draw a switch right here and I turn it on, then this one will be on. If this is turned off, then it will be off.
This one
Right.
is on?
Yeah, so this one has no switch button. They're both on. So right now, they're both on. Okay? So question 1. So here's the diagram. Question A. Find the equivalent resistance for the circuit. Okay? The equivalent resistance in this case will be the total resistance, right? I could also call it equivalent resistance when we work when we look at network or combination circuit. It can get really complicated, and I say what is the equivalent resistance only in this small part. But in this case, the equivalent resistance is the total resistance for the circuit. Okay? So how do we calculate that?
1/6 by 1.
Okay, can you guys do that then? 1 over RT equals 1 over 6 plus 1 over 4. Okay, so in your calculator, let's do this as fast as we can. So all you need to do is find your button 1 over x, or x to the negative 1. Look at this. I just go 6. Press the button. Plus 4. Press the button. Press the equal sign. Press the button one more time. The answer is 2.4. That saves you so many buttons to not have to press. Okay, so instead of going 1 divided by 6 plus 1 divided by 4, use the button. Okay, so the RT is 2.4 ohms. Now, make sure you guys can get this right now with your calculator. Go and try it. Okay, again, look, 6. Press the button. Okay, plus 4. Press that button. Equal sign. You got 0.416. You're going to have to press that button one more time.
It's okay, go ahead.
The answer is 2.4. If you do it the long way, you're going to go 1 divided by 6 equals that. Okay? plus 1 divided by 4 was that. So this is the total. And then you're going to go 1 divided by 0.416. You still get 2.4. That's too many buttons to press.
But I have the X minus shift.
Yeah, that's what you use. So try it again. Clear the button.
Yeah.
Okay, 6. Press that button. Plus 4. Press the button. Equals. Press the button one more time. 0.416 is actually 1 over RT. You want RT, not 1 over RT. So you're going to press the button one more time. Okay? Because what you'll get, 1 over RT is 0.41 something, right? So to get the RT, you're going to need to inverse the 0.41. So you get 2.4. Are we okay? Okay, so that's question A. And that makes sense. Take a look. So the resistance here, you got 6 here. The resistance is going to be less. That's the nature of a parallel circuit. But now let's take a look at question B. You're looking at potential difference. What's the other name for potential difference? The voltage, right? So you're looking at V1 equals V2 and V2. They're not going to be the same because they're different resistance. What is the V total? 12 volts. Now we're looking at V1 and we're looking at V2. If this is the same resistance, if it's the same number of ohms, they will just split the volts evenly. But they're not the same. So here's why, by the way, the voltage will split. Look at this. So current is going to come out this way. Think of it as now you're encountering the resistance number 1. That means for you to actually fight this, okay, you're coming out with 12 volts. So 12 volts going this way, right? So that means then when you go this way, all the 12 volts will go there because you don't have to fight 2 of them at the same time. So you can actually do it one at a time. So you can go this one path, that's one path, right? So that means all the 12 volts can go here. So this will take 12 volts. And then the other 12 volts will go here, and you don't have to fight number 1 to fight number 2. So 12 volts will actually be taken up by the 4 ohms. So what is the same in a parallel circuit? The voltage. So that means if the total volts is 12, V1 is going to be 12 volts and V2 is going to be 12 volts regardless of the number of ohms that they have. This could be 1,000,000 ohm. And the other one could be 1 ohm. They're both going to receive 12 volts.
Doesn't matter. Right?
Does not matter.
Okay.
So you need to remember what are the same in a series circuit, regardless of the resistor, is the current.
Yeah.
In a parallel circuit, what is the same, regardless of the resistance, is the voltage. So once you've identified what is the same, then you can answer the other stuff, right? So for question C, you're looking for the current delivered to each resistor. Okay, so now we're looking for I1. This is when we can now apply Ohm's law. So what we've done so far is apply Kirchhoff's rules. Right now, we can use V equals IR. This is Ohm's law. Okay, so if you're looking for I1, well, isolate your I, you go V1 over R1, and that will give you the current running in the first resistor. So what's V1? What is the volts running in the first one? 12 volts. What is the resistance? 6 ohms. Okay, so 12 divided by 6, 2 amps. So the first one is going to receive 2 amps of current. Okay, what about I2? Because they split, we'll need to find them differently. They're going to be separately, right? So V2 over R2, V2 is still 12, and R2 is now 4 ohms. 12 divided by 4, 3 amps. Okay, so combine these two, and that will give you the total current. That would be 5 amps of current for the entire circuit, but they will split because they have to take different paths. Okay, so that is question C. Question D, find the power dissipated in each resistor.
So which one is need more current?
So, oh yeah, that's a good question. Which one needs more current? Look at this one is taking 3 amps, and that is your R2. Why is R2 receiving more current? R2 has only 4 ohms. R1, which is getting 2 amps, is getting 6 ohms. Y is the one with the less resistance getting more current. Less resistance. Remember, resistance is kind of like friction. It's fighting you. So if you're going to fight less, you're going to receive more current. The more you fight, the less current you're going to receive. Does that make sense? Makes sense, right? Okay. Okay, so question D, find the power dissipated in each resistor. So now you're looking at P equals IV. So if you're looking at P1, they're going to go I1 times V1. What's the current in the first one? 2 amps. And the voltage is still 12. So 12 times 2, 24 watt. Okay, so that's the first power. Power number 2 is I2V2, which is 3 amps times 12. So 12 times 3 is 36 watt. What is the total power dissipated by the entire circuit? Total power is 60 watts. That's question E. The total power dissipated by, delivered by the battery is 60 watts of power. You can also calculate the power by PT equals IT times VT. And just to confirm it, what is the total current? 5 amps, right? The total volts is 12. 12 times 5, 60 watts. So we've just calculated it 2 different ways and you get the same answer. That makes sense?